Hello everyone, welcome to another lesson, lesson 8 this time. Remember, please put your questions in the comments. It'll be good to hear from you all and see if you have any questions. You might do about this one, because this is arguably the hardest part of the geography GCSE. It's certainly what I found hardest when I was doing GCSE geography. It's the intertropical convergence zone, it's the global atmospheric circulation model, and basically it's the start of tropical storms and weather hazards. All right, can be a bit dry, but ultimately you have to know it. There's always a question somewhere on tropical storms, somewhere on atmospheric pressure, so you have to know what's happening. I'm going to try my best to do this slowly. This is a video you might want to pause, re-watch, rewrite notes on. By all means do that. That's why I'm making these. I'll try and make it as clear as I can as well, because this one I need the board for. So, the global atmospheric circulation model. That for the minute is just a circle. But the global atmospheric circulation model, global, the planet, atmosphere, in the atmosphere, circulation is movement, model, the model to show it. Okay? And the first thing to note is right here, I'm going to draw it as best I can, without any sunglasses on, is my sun. Okay? I've drawn a sun there because this is what starts the whole thing off. The solar radiation coming from the sun hitting the earth. Okay? I've drawn it right there deliberately. I've drawn it near the middle, right there, deliberately, because that is where the concentration of solar radiation is at its strongest. Okay? That line there obviously being the equator. Okay? Now what basically happens is the sun heats the equator, it heats the whole planet, but let's say it starts at the equator, and the way the air moves around the world is dependent on starting here. Okay? So, the next thing I'm going to draw is a little dash here and a little dash here. Now these are 30 degrees and 30 degrees. I do not mean temperature. Temperature is to do with latitude. Okay? Now latitude is how north or south of this point here, 0 degrees, the equator, you are. How north or south of the equator you are. So, here for example, 0 degrees is on the equator. The number goes higher the further north or south you go. The highest it could be right up here is 90 degrees north. The lowest it can be, symmetrically, is 90 degrees south. Every number in between is closer or further away from the equator, relies on temperature. The closer you are to here, the warmer the average temperature over the year. The further away from the equator, the colder the average temperature over the year. Excuse me. So I've drawn 30 degrees south, 30 degrees north here. Now they're called cells. So this first one here, near the equator, from the equator to 30 degrees north and south, is the Hadley cell. Okay, Hadley, Hadley cell. Now this is the cell obviously nearest the equator. Okay, we do a little line here and a little line here. From 30 to 60, so the next one, excuse my pen there, 30 to 60, it's not the Hadley cell anymore, it's the Ferrel cell. This is where the UK is in the Ferrel cell. So Ferrell, north and south of the equator. Hadley, Ferrel, and the last one, probably the easiest one to remember, 90 to 60. So we're 60 degrees here, north, 60 degrees south. The last one at the top here is the polar cell. Again, down here as well, the polar cell. So those are the three cells: Hadley, feral, polar. I've drawn 6, but they're 3 different cells, north and south of the equator. 90 degrees, 60 degrees, 30 degrees, and right in the middle here, on the equator, is 0 degrees, okay? Now, this is how weather patterns emerge. This is how the climate is. This is how air moves around the world. Just to remind you, don't get confused. Temperature is nothing to do with what cell you're in. Temperature is about one word, and that word is latitude. How far from the equator you are, okay? Key to remember, latitude, it determines the temperature. So, at the equator, I'm going to come over this side now for a moment. I'm going to put a little L there. At 30 degrees south, I'm going to put a H, and then a H. So it doesn't stand for Hadley, that. At 60 degrees, I'm going to put L. And 90 right at the top, I'm going to put a H again. So HL, 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 H. I'm hoping you've worked this out already, but these stand for high and low pressure. So, at the equator it's low pressure, then it's high either side, then it's low. It's like an alternating high, low, high, low, high, low. So why is it like this? Well, ultimately, at the equator, it's low pressure. What does that mean? Well, because the sun heats the surface, because of solar radiation, what's going to happen to the air? It's going to get lighter because it's going to get warmer. So when air is warmer, what happens is, the air is here. I'm sure you can see that little dot there. What's going to happen is the air is going to rise up. Okay? So air rises at the equator. At 0 degrees, at low pressure, air rises. Really important to remember. At low pressure, air rises. You may remember me not pushing someone's head down. Low pressure, air rises because it's lighter, it's warmer. So as it rises, it does 3 things. So at low pressure, you get cooling, condensing, and therefore you get clouds. So low pressure, it cools, condenses, clouds. Feel free, by the way, to do this along with me if it helps. So low pressure, you get cooling, you get condensing, you get clouds. Okay? Therefore, if you get clouds, what else do you get with that? You're going to get rain. So the way I remember it is low equals lousy. Lousy weather conditions. What is lousy? As it's cloudy, I'm going to do my terrible drawings here. It's rainy. It's cloudy. So you've got rain, cloudy, and stormy. Windy, that kind of thing. So if you're thinking ahead of tropical storms, it's going to be low pressure involved, isn't it? So low pressure cools, condenses, clouds, therefore you get lousy weather, therefore you get rain, clouds, stormy weather. Okay? High pressure is literally the opposite. So if you can remember low pressure and what that means, then high pressure should be even easier. I'll come down here. High pressure. If air rises at low pressure, down there just to remind you, air rises. If air rises at low pressure, if air rises at low pressure, what happens at high pressure? The opposite. It doesn't rise, air sinks. Because it's heavier, it's not lighter. Exactly opposite. So, the air sinks at areas of high pressure. Okay? So for example, here at the equator, it's risen up, it's then spread across, and this area of high pressure, it's going to sink back down. Therefore, it's the opposite. Does it cool? No, it warms up. It's the opposite, it warms up. Does it condense? No. Is there any clouds? No. So I dictate this as happy, smiley face, weather. Okay, happy weather. That means clear skies. That means calm, no wind, no storm, clear skies. And if you get clear skies, if you get no clouds, it's going to be dry. So areas, for example, like the desert, are going to be high pressure because it's dry. Areas like the rainforest are going to be low pressure because it's rainy and cloudy. Okay? Now, ultimately, that is how this works at all these different stages here. High, low, high, low, high, low. So you know on this map, if you see a low pressure area, for example here, like in parts of Australia, it's low pressure, it's lousy weather. Does that check out? I mean, yeah, the rainforest. I'm a Celebrity, Get Me Out of Here. It's filmed in Australia. What about up here? H, 30 degrees north of the equator. Makes sense to me. That's the Sahara Desert. Dry, no, not very much clouds. Easy. Now, the last little couple of bits. There's a lot of stuff to process. I understand that. Next time, we're going to be looking at how tropical storms form. But for now, a couple more things. In this area here, between 23 degrees north and 23 degrees south, you have something called the Intertropical Convergence Zone. Intertropical Convergence Zone. Where the tropics meet. Intertropical, between the tropics. Convergence, where they meet. Zone. That is where you get tropical storms forming. So tropical storms only happen here. That's why, at the moment, without climate change at least, you get no tropical storms up here in the North Pole and no tropical storms down here by like South Africa. They only happen between 23 degrees north and south of the equator. Okay? Now, winds are always moving. We've seen how air rises. We've seen how winds happen. Now, you may see a map in the exam. They may use a figure. There's lots of figures where you have curved winds that look a bit like that. Okay? North and south of the equator. Curved winds. Now, why do the winds curve? That's something called the Coriolis effect. For this one, it's actually easier to use this bad boy over here. Okay? Because the Earth is spinning all the time. Okay? Now, if you draw a straight line down here, that's a straight line. If I draw a straight line as the planet turns, suddenly my line isn't straight anymore, it's bent. Basically, that is how the winds curve. They're deflected by the spin of the Earth's rotation. Okay? That's where you get trade winds, and that spin is enough to generate energy for a tropical storm. A lot to process. One final thing for this video. I'm sure we can go back and watch this and definitely ask questions in the comments for this one. A question you may get is to describe distribution. Where are things distributed? Where is low pressure distributed? Where are the biomes like the rainforest distributed? On a world like this, well, even on a world like this, it basically means where something is spread out. Where it is located. If you're asked to describe the distribution, you're describing the spread of something.